On August 10th this year, Open Cybersecurity Schema framework was unveiled in Black Hat Security event. Today, we will briefly talk about it, touching upon its background, taxonomy, and my views. Let's first understand the genesis. Where did it come from? I think we all would agree that today threat landscape is expanding faster than ever, and SecOps teams are finding it very challenging to detect and rapidly respond to these threats and attacks. In fact, the recent study data by ESG also shows that it's not that they don't have access to tools or data, but the biggest challenge seems to be in normalizing, correlating data from all these tools and maybe other sources for reasons which can be mostly attributed to the fact that many of these tools refer to same things with unique or proprietary terminology. With all these challenges put forward, and in order to break down data silos by integrating security tools and resources, AWS and Splunk started OCSF initiative, which they thank Broadcom for, because they have built upon ICD Schema, which was actually developed by Symantec, now a division of Broadcom. And it also included contributions from 15 additional members like Cloudflare, CrowdStrike, DTEX, IBM Security, you name it. You'll find most of the big security vendors out there, which is a good thing if you see. They have put forward the mission to create an industry-wide framework for data exchange, aggregation, and analysis. Would that not be great? And another aspect out here is that this framework is not exclusive for cybersecurity use cases. I think if this really works out, it is going to be great that other industries or verticals can also make use of it. This is licensed under APL 2.0. It's an extensible framework, it's vendor agnostic, yet it is not restricted to cybersecurity domain, or for that matter related only to the events. This project is aimed at delivering simplified and vendor agnostic taxonomy. I think it is important for us to understand, and and this I'm saying for people who are not from the security operations industry, that problem discovery and investigation often requires correlating logs and metrics data from various devices and software, be it like devices sitting on the edge of your network or cloud or virtual or real. The data coming from all these is like mammoth. Just imagine a packet for every a log for every packet that gets transferred through a device is like crazy, and this needs to be mapped up with maybe let's say for example I need to know which IP address, which machine, who was using this IP address and things like that. This can go in so crazy with the the interconnections and interrelations that the SecOps teams work on to try and find out where the challenge really is, or where the attack originally emanated from, things like that. And it is expected that by adopting OCSF schema as the format of this metric and log data, and I can say by looking at the schema, it should become easier to correlate this data, because they are simplifying a lot of things. They are normalizing, avoiding the normalization actually, because they are doing the normalization in the beginning itself. So we can expect better and faster analysis, which should help the security teams in achieving the key goal of defending organizations from cyber attacks much faster. Now let's try to take a deeper look into the framework and understand how it is trying to solve the problems. Uh, you know, let's begin with the way it has been published and made public. So OCSF actually created 4 repositories which I could get information on. If there are any others, I really don't know, but as of now, as of this recording, that's the number. So they have created a governance repo, and this all information, by the way, is on GitHub. So it's in public domain, to store all the governance related documents, with it talking about all the governance stuff. So let's leave it for there at the moment. They have a repo called OCSF docs to store relevant proposals and documentations. They have a repo called OCSF schema, and that's the key repo which contains the normalized schema, or let me put this, normative, sorry, the word is normative, normative schema in JSON files format out there. If you look at it, it is split across various folders, and there's a structure that they're following out there. I also, when I was reading through the documentation and some links and content on this repos, I came across another repo called OCSF server, which actually is still private, and I raised a ticket for it because I think looking at OCSF schema, probably we could understand how they are trying to correlate all these schema files and work together on that thing. And also I discovered the contributions to these the schema repo are actually increasing since July this year, which looks like a healthy sign, or it could be because that they had to launch it on the 10th of August. We'll know. I think we'll know very soon how frequent these changes are. And I would recommend all the listeners to go through OCSF docs first to understand the schema and taxonomy before jumping onto OCSF schema repo. I'll try to cover a couple of elements from these documentation that I came across, and I think which are probably generic in nature. I'll leave apart some things which are too technical, like for example how the variables are named, or the attributes are named, and things like that. So I'll only try to cover the basics about this. So in this schema, they have actually defined 4 personas that are also the users of framework, but personas are also like the hats people could wear, or the vendors could wear, or the organizations could wear. There's like producer, which is basically generating events in the schema. In schema, when I'm saying in schema, it's basically using the schema definition, structure, and generating events. Then there's an author, which creates an extend schema, or should I say it's like a chicken and egg story. Actually, author creates the schema first, and the producer actually is using that schema. So author could be one who has originally defined the schema, which most likely is going to be the OCSF team, but and then the schema could be extended by vendor to address certain what should I say, attributes which are not covered by the original schema definition. So they could extend it. So that's where author comes in play. Then there are mappers. Now, do we need mappers? Probably yes. That could be transition phase, honestly speaking. And mappers could be something like today, in today's state, let's look at it. The schema definitions are very vendor specific. They are very private, or proprietary, and vendors could write mappers instead of rewriting their application code to address this, and they could write the mappers which actually performs the translation into OCSF schema, and which could be a quick win for most of the vendors, honestly. And I think the actual user is analyst, which is driving this entire need, and which is responsible for writing the rules or performing analysis against the schema, and things like reporting, etc. Now let's talk about taxonomy. OCSF taxonomy has 6 fundamental constructs to it, which could be defined as data types, attributes and arrays, the attribute dictionary, event classes, categories, profiles and extensions. Now let's take a moment and talk more about it, what's covered in this, and I'll try to keep it brief, but I think this is something which is important for everyone. So data types are basically, if you're from technology background, you understand what data types are, but what kind of data types the OCSF is using, let's look at that. So they have used primitive, scalar and complex data types. The examples that I could probably come across for primitives are like, for example, strings, integers, floats, booleans, etc. For scalars, they've used like timestamp, IP addresses, MAC addresses, usernames, etc. Complex could be like, for example, process or a device, file, and these complex data types could themselves have other data types which are contextually related to it. Like, for example, a process would actually have a contextual relationship with file, which will have a contextual relationship with device also, because process is a result of a file being executed, and the file is residing on a device. And also look at it, a process would be executing under a user namespace, executing as some user, so it would also have a relationship with user. So you could look at it, these are like entities which could include other entities. Similarly, like attributes would be, and honestly all these entities would have their own attributes. So attributes are basically the I'll say the fundamental building blocks of schema. It is an unique identifier for a specified field, along with the corresponding validation information that I could see in the documentation that they are referring to. So most scalar data types, like timestamp and all that we spoke about recently, they have defined constraints on their valid values. Like, for example, IP addresses, they could be either IPv4 or IPv6, but they have their own set of rules which must be followed for these data types. Or for example, even in case of timestamps, that would hold true. So they put in some or they're expecting to put in some kind of a validation values out there, and attributes could be actually further grouped into maybe for documentation purposes 4 categories. Like, for example, they could be primary attributes, attributes for classification, for occurrence and context. So in the OCSF schema, the attributes that are important for taxonomy are designated as classification attributes, and in the schema or in the event class, within the schema, you'll find them often marked as attribute, or rather, actually, I think they are always marked as required attributes as part of the event classes. Any attribute in the from the occurrence side is basically time aspect based. So, like for example, event occurred at what time, when it was discovered, when it was logged, when it was updated. All this information are basically, these all attributes would be defined as occurrence attributes. Similarly, attributes which are used to define the meaning, or they could be used to enrich the content of the event, could be defined as context. And one good example that that comes to my mind at this point in time is, let's take a denial of service attack, or even for example a port probe is happening on your network. And that port probe, when it's happening, the information that is available to you is only the IP address from which it is originating. But the other attributes about this IP address, like for example your ASN number and other geographical location, all those things, you will probably map it up and pull it up, update this information later. So you're enriching the event so that by looking at the event, I can or security analyst could get a better understanding of the event, and they don't have to perform a lot of mapping, but yeah, they have to do mappings otherwise. But yes, from this particular event perspective, they can probably get more of information. And now this could be a very vendor specific thing, but yes, this is an example that I could probably come across. Now all these attributes are actually stored in a dictionary called attribute dictionary, which the name itself implies. Then there are event classes. So what are event classes? I think it probably is one of the easiest thing to explain out here is, so it's basically a structure of event structure with a set of attributes which help describe the semantics of event in detail. A event could be, a port probe is an event, so there could be a class against a port probe which could define the whole operation of port probe, but this is a network activity if you look at it. So they have defined like for example network activity event, which could have other aspects related to it. Then event classes are also grouped. They're grouped into categories, and one important thing that comes to my mind is, for all these things, they've tried to come up with unique IDs. Like for example, schemas, event classes have schema unique IDs. Categories have unique identifier attributes, and even these categories could have attributes in the context of event class, which can be set to required or recommended or optional. Coming to profile, profiles overlay additional related attributes into the event classes and objects for allowing cross category augmentation and filtering. Example that comes to my mind is it's probably a system activity. Let's take an example of a system activity which is happening on any host for that matter. May also contain, the class for system activity may also contain info attributes about malware identification, in case the information about system activity is coming from what would a security product. It could be endpoint security product which is providing this or producing this event, rather I should say. Then they would also probably include malware identification attributes if that is the case. And one very important thing which we discussed about earlier also, about the extensibility about the schema. So they have something called as extension in the taxonomy, which basically allows schema to be extended without modification of the core schema, and they put together a complete document on how the schema can be extended with certain examples in that. After reviewing the available documents on the GitHub repo, I would like to conclude by saying that OCSF framework is currently in development stages, but it holds high potential for SecOps. You know, from my point of view, I would like to see some of the items extended upon, you know, for an early adoption, maybe as consumers or for, you know, third-party agencies. Uh, some things that I could not figure out, for example, was, you know, how to, you know, include all the files which they have, you know, scattered across different folders, to build up a consolidated schema for, you know, for the consumption purposes, or how to validate a particular JSON against the schema which has been defined, things like that. uh, you know, on the first look of it, or after going through the JSON files, they don't appear to be have been built in using JSON schema. In fact, someone had raised a ticket on the repo also, and they mentioned that JSON schema is not fit for their requirement, and the request is on it. The issue is still open, where they've requested that, you know, some kind of a standard specification should be used, you know, so that at least some flexibility is there for other people to work upon. From my point of view, you know, coming from Python background, and for me it is important to be able to translate a schema into, you know, data model classes, which probably becomes easy to process in the Python, which I don't know how soon it will be available. Also, I would like to see some examples on how to use schema as consumers, you know, things like that. And before I go, you know, and this part I had to edit, sorry. I just learned about, you know, the OCSF server schema being made public. Thank you, OCSF team. It has been made public about 8 hours ago, as I can see it, which is a great thing. I would be studying more about it. This has been, on the first look of it, built using Elixir, and uses Docker technology and all, but more about it maybe in a later video. For now, I would love to have your thoughts and views about OCSF, its probability of use, and, you know, how likely you are to adopt OCSF schema as a, you know, maybe a consumer or a vendor, or a, you know, your views as a SecOps team. All this will be really helpful. Thank you very much for listening to this video. I would look forward to, you know, seeing your comments. Thank you very much.